join me in welcoming our next speakers to the stage to discuss the invisible process that controls your data center's fate.
Good afternoon, everyone. Welcome to this panel. I'm Louis Charlton. I'm the Group CEO of the GCV Group and Global Commissioning. For the next 45 minutes, we're going to talk about a subject which is something that doesn't get spoke about enough in the industry, that I believe. The industry talks about commissioning as being just a milestone at the end of construction. I think everyone on this stage probably agrees that's not true. And the more that the industry talks about this subject, I think the better outcome we'll get from projects. We'll kick off. I'll introduce the panel first, and we'll kick off with some questions. So we're pretty lucky at the panel that we've got today. We've got sort of the full life cycle of projects. So we've got Jamie in the design seat from Equins. We've got Laura from the OEM side. We've got Aidan from the general contractor. Phil Hayden from the CXA, and Phil Collison from the end user Advantage. So we're going to move through a number of sections in this talk. We're going to talk about what commissioning really is, what discipline looks like across the life cycle, how traditional delivery models don't really work, that the projects have changed a lot in recent years, and we're no longer delivering the projects the same as what we were maybe 5 years ago. And we'll just talk about how we see the industry change and how important this process is. So we'll start off with a really easy one. Jamie, I'll come to you first from the design side. From the design seat, what does commissioning look like, and when it's treated as a discipline rather than a final stage activity?
Good afternoon, everyone. Thanks for coming up today. So what is commissioning from a design perspective? I suppose commissioning is the ultimate verification of the performance of the systems, in essence. What is commissioning in a data center is maybe a lot more than that. In terms of the process that we follow to commission a data center, that starts in design. It starts in terms of actually making sure that we've got clear inputs, in that design process, so that we can come out of a design stage on the various design stages, actually looking at the design and whether that's going to meet the performance that's going to be required. So getting clear input to start that process off on the right foot, making sure that the design is going to deliver the performance that the systems require. And then from that point, going into the commissioning process alongside the construction activities, starting right from even before delivery with FATs, ultimately building then to the culmination where system level testing and integrated system testing of those systems. So.
No, excellent. I think that's where a lot of people get it wrong, is they don't take it serious enough at the design stage. So I think it's really important to emphasize how important the process is in the design stage. So Laura, from the OEM side, what role can the OEM play in proper commissioning when it gets to site?
So to build off of what Jamie was sharing, I believe that the OEM is truly embedded throughout the life cycle of commissioning, and that starts with the design phase. We're sanity checking load profiles, making sure that the equipment can run off of those load profiles in a real use case. I would say most people believe that the OEM's sole contribution to commissioning is the factory acceptance test. But really, we're embedded in design, in the site acceptance test, in the IST process, as well as the handover to site and the life cycle of operations. So the OEM piece of commissioning truly is the continuity thread through all pieces of the commissioning process.
Yeah, no, I totally agree. And Aidan, as the general contractor, what's true, or what do you find is the benefit of a project that takes the commissioning seriously from the design stage to the end, and how do you think that benefits the project?
For us being engaged early, we are lucky that we have a unique perspective. We work with so many design houses and so many vendors. So we get to see a lot of first of kinds. It is critical to be involved at the design stage, because we look at the CDEs. The sales teams will always put a commercial position forward to try and make their bid more attractive than their competitors. Sometimes it's only at the very late end of commissioning where we're going from level 3 over to Phil's team and level 4, we'll start to find the scope gaps. At that stage, it's too late to fix. So we're lucky that we can see that early. If we're involved in the design team early at REBA 3, REBA 4, we bring those lessons learned from each of our stakeholders, all of our teams. There's probably a coin phrase there, lessons learned, that people kind of take for granted and sometimes like pulling teeth. We see those as very valuable information transfers. We'll always keep a playbook, whether it be a UPS, a generator, anything at all, an STS. What were the last issues we had? What were the comms issues? What did we do to resolve? And more so, what can we do at the next stage? What's the earliest point that we can ask the question to intercept that and make sure it either is not a scope gap, or if it is a scope gap, how we deal with it at the design table. System losses as well. We shared some very good information there recently for one of the design teams where the forecast system losses were one value, and we were able to show them our pneumatic data that we did at level 3 to show here is the actual system losses all the way through. They're not used to seeing that information, so that's where we pride ourselves in our data capture to share that with the rest of the team to make the whole life cycle better.
No, excellent answer. And I think one of the important points is the lessons learned in commissioning. A lot of lessons learned don't get passed on from project to project, even within same client teams. Lessons learned is massive in the industry, and it's an excellent point. I'll come to Phil Hayden now. So what does good commissioning actually look like, and what's the biggest way that the industry still gets it wrong from your point of view?
Yeah, thanks, Louis. So for me, good commissioning looks like a whole turnkey package from design, working through the issues, checking that we can actually commission the systems. The amount of times we see failures too late in a process when you're engaged later than everybody else, or you didn't have the option to visit the factories, understand exactly what the OEMs require to actually deliver the project. Fundamentally, they kind of bypass the beginning, and that's what's actually wrong within the industry. The earlier the engagement, the better we will deliver, and that's fundamentally where we're at.
Oh, excellent. Just on this, obviously I'm aware that some people may not be aware of the process. Can you just give a very quick overview of the commissioning process at each level and what it could potentially mean? I don't know if Aidan wants to assist with that as well.
Yeah, again, it's kind of a thing. People hear these phrases, and there's a number of different things, whether it be commissioning levels, level 1 or level 0, red tag, yellow tag, green tag. Everybody has a different nomenclature that they use. So there's a stage of the commissioning where it's at Jamie's stage. So that's the design stage. We then, through a team, we select the equipment, and it goes to the likes of Laura, whereby it's a factory witness test or a factory acceptance test. The importance of a good factory acceptance test or witness test is that's where you get to test this piece of kit. It's like when you're on a plane and the air hostess or the captain says, you've been on lots of planes, but you haven't been on this plane, it might be different. What communications protocols are we using from an EPMS or a BMS point of view? Have we all the correct Modbus registers? They're a 5-minute fix in the factory because you have the relevant skill set and stakeholders to do it. But when that gets to site, you might have to fly a technician. You could be 2 or 3 days waiting for that technician. You could have 15 to 20, 30 people on site waiting for that. So asking the right question early is critical. When it comes over to us, there's an important metric there this morning that Noel said from Microsoft. In the last 18 months, they have handed over the same capacity that they did for the last 15 years. That's a 10-fold increase. So everybody here, whether it be Phil representing the client, Jamie representing the design team, Laura representing supply chain, and then Phil, who I hand over for commissioning, we're trying to compress that 10 times workload in now into all of these schedules. So when we do our level 3s, that's where we basically do the startup. We're butting through the energy as per the what's called basis of design or the system of sequence of operations. So whether it's a UPS, an SDS, an AHU, it's incumbent on us to make sure it is tested to 100% of its asked capacity for on-site. So that when we hand over to Phil, as Phil rightly said, if we miss anything or if anything's missed at the factory stage, Phil and his team have no time to recover. So it's through our experience to get each of those steps over. We like to do within Winthrop Technologies what we call a GC system level test, which is a mini system level test where we hand over to Phil's team for a system level test or an IST test that allows then Phil to hand it over to client operations. So that's each of the life cycles. Another phrase that people would use on site and we like to communicate is megawatts. And people don't understand the hazards that we have to control when we're talking about megawatts. And to put it into perspective, if Laura or the supply chain are supplying a string or a power module and we start loading that to capacity, we're basically pulling the same amount of power through that as the equivalency of 3,500 households cooking at the same time. And that's going to be in one breaker the size of this chair. So again, we have to manage all that from a safety and efficiency point of view so that when we hand over to Phil, He touched on equipment failures. We see equipment failures in the industry, and equipment can and does fail, but we have to make sure we keep all of our team ready for that through to level 3, into you for level 4 and IST, and then over to Phil Collison's team and the likes for operations.
Yeah, I think on the misconception of commissioning, commissioning doesn't start at level 4. We don't just all of a sudden go, now commissioning starts, now we look to hand over. The whole life cycle that Aidan just spoke about there, that needs to be captured. That is the critical parts. And like you said, starting that at very early stage into design. And then when we get to level 4, proving equipment to its maximum capacity and finally into an IST. But fundamentally, like I said earlier on, you need that process throughout the entire life cycle. And it starts with design. And the earlier the engagement for the entire commissioning process, the better it will come out the other end.
Yeah, I think that's an important point, isn't it? The word commissioning is misunderstood. I think people think it's a one-time exercise. It's actually a life cycle. It's a life cycle event. It happens throughout the whole process of a project. I think it's what you've touched on as well there, Aidan. Safe system of work is really important in the industry, and we'll come on to it. But it's a good capture that all of these activities, all of the sim ops, the phase delivery. We'll come on to lead time soon, Laura. All of these have an impact on the safe system of work and how we're energising projects in different phases, what that means to the safe system of work, what that means to the process. So it's a really good point, and it's something I do think gets overlooked on some projects. The industry's grown at such a rate, delivery times are getting squeezed. Everyone wants we'll come on to the end user in a minute, Phil's smiling, but everyone wants their data centre yesterday, but there's a process that has to be followed, and I think it's really important. So Phil, from Vantage, so from the client side, when you engage a CXA, what are you actually buying? What do you think you're buying when you engage a specialist?
Hello everyone. So when I started at Vantage, it was very different in the approach of commissioning and what commissioning was. Global were already in that position for Vantage when I joined, but we changed that process quite dramatically to bring you in far earlier in the engagement, very work stage 2 design stage, so that you was looking through the commissioning lens rather than just thinking of it at the tail end, right? Commissioning is not at the tail end. So when we go to companies like Global or Winthrop or Bouygues, or Engie, sorry, to Equans to do the commission on our behalf and prove that facility, we're not just looking at can we commission it, can we reach an RFS? It's really, can that facility last 25 years? Can we have that life cycle of that investment? And it's a huge investment out there. These facilities are only getting bigger, and with them getting bigger becomes bigger targets. We're not talking about delivering 4, 8, 16 megawatts at any one time now. We're looking at 40 megawatt deliveries, 60 megawatt deliveries on 40 megawatt, 60 megawatt chilled water systems that had never been done, especially in Europe before. I know the US has sort of ventured into that package, but especially in EMEA, we've not done that. And the demand is getting more and more from our customer perspective. They want Q4 28 at the latest, and we're not even spade in the ground on some of the facilities. So it's an extremely tall ask. And that brings us into that new world of commissioning now. We're ripping up the rule book, we're changing our approach, we're going DFMA, and that will involve the GC right from the very start. Someone like Aidan coming straight in from the very beginning, work stage 1. We've got a test fit. And we look at that test fit and we examine it, and then we come up with a strategy that's going to aid us, not from a design perspective, not from a manufacturer's perspective, but everybody working as one team. And it's really crucial that we all pivot that way. Something we are seeing on all these events is the focus on commissioning. And it's really been good to see over the 4 years that I've been at Vantage, we've really brought focus into commissioning, and how much commissioning can give to design, can give to the MEP installation, right? Building those blocks together to ensure that we get a smooth, seamless process that then allows Aidan, Phil, to prove that facility's design and maintainability.
No, excellent answer. And you touched on something there which got us thinking about, we're in a huge CapEx phase now in the industry. Eventually we'll move to an OpEx phase. And this is where the life cycle for equipment, maybe redesign, everything comes back around. You talk about 25-year life cycle. I think with some of the higher densities, we're maybe talking shorter periods of time for refit and change of chips, which will need re-verification. So I think it's really important to understand that commissioning isn't just a construction. I said at the start, isn't just a construction milestone. It's really a life cycle. It's a life cycle.
I think it's a great point what you bring up, Louis, that The new technology now with the AI racks, where we're looking at that, they're 160 megawatt, 60 kilowatt racks now. In 2 years' time, that's going to be a 500 kilowatt rack. So how do you pre-plan for that? Well, you don't to a degree, but you have to have an intelligent design. Jamie's role to ensure that we've got capability to ramp to that stage, right? The densification will happen in those spaces. You'll use far less footprint on a far higher density. And it's tough to know what the right foot is forward because everybody's doing it slightly differently. But what we are noticing, and especially with the link up with the other businesses here, the same as Vantage, right? We're talking on the same page, and we're actually learning and bringing the industry up together, which is really critical.
Yeah, and I think it touches on what Aidan mentioned, you know, the expectation to deliver 10 times the capacity in the same period that we are delivering a lot smaller capacity 5-10 years ago. I think, you know, that's the challenge. And you spoke about the rack sizes. I think, again, coming back to safe system of work, you know, we're going to get into HV, DC rack feeds, which is a total different ballgame when it comes to managing process, energization, everything. I think we're heading into a real different space in delivery over the coming years. So just on that, so talking about the life cycle, then you touched on Jamie and design. So Jamie, do you want to just walk us through what commissioning should look like from a design during the design phase?
I suppose it starts maybe 1 or 2 steps before design. You know, as a GC, as designers, you know, we're looking for information, you know, to brief that design, to get the basis of design right. So we're looking, like most people through the construction phase are looking for, is the key information that we're going to utilize, you know, and trying to define that fully. So working with customers like Vantage, who are looking at development opportunities. They might not know their end user. They probably won't know the technology. How do we go into a design process with those unknowns? So, you know, obviously you have to have an approach. You know, we're talking to different customers, different developers about, right, in the absence of the specific information, you know, what is your approach? What is your standard? Have you got a standard? Have you thought about having a standard? You know, quite often comes up. So, you know, we're then saying, right, what technology is going to be employed? You know, most facilities that we're building, have been building for the last few years, have been built as air-cooled facilities. I think the word of 2 years ago was pivot. You know, we're seeing, you know, facilities that have pivoted. You know, we're building air-cooled facilities that are now fitted out with liquid-cooled equipment, at least in part, or in some facilities that we've delivered recently as a whole. You know, and that's certainly not where they started from. So, you know, it shows that that challenge is real. But within that framework, you know, the commissioning process was anticipated to some degree, you know, in the design phase. So, you're working with customers in the development phase, working through even during the construction phase where an end user might come on board and actually be clearer about their requirements, to actually then go back to design, you know, to say where the design is challenged, to make sure we incorporate that. Yeah, so the whole process relies heavily on that collaboration. It's not step by step, painting by numbers. There's a reason why we need competent people in the industry. You know, the process is not, you know, a Haynes manual of how to build a data center. It's, you know, it's a dynamic process that needs intelligence, so needs control as well. You know, some of the biggest challenges we've seen in commissioning are where, you know, there's change and that isn't controlled. You know, design changes get made but not completely thought through when the initial process was followed. So, you know, we're as designers, as builders, we're looking to manage these process. We need collaboration right from the start. You know, we need to recognise the challenges as they come, talk about it openly. You know, we need everyone around the table. We need the customer there. You know, we need the end users to be as forthcoming as they can with information. Sometimes they can't be forthcoming because they might not know themselves, given the dynamic market we're in. So, you know, the whole process is reliant on that, you know, brain power, communication, systems of control, you know, making sure that, you know, we're all aiming at the same result, you know, we're converging on that result correctly.
No, I think it's a big one, collaboration. I think, to win the race that we're in, to deliver all of these large projects on time, it's all about collaboration across all of the life cycle of the project. So back to you, Laura. So factory acceptance testing, I think a lot of the industry treats it as a bit of a tick box exercise. I think we're going to a factory test and ticks a bit of a box. What are you guys actually proving when you do the factory testing? And what does everyone underestimate about factory testing?
Yeah, it's true. So most people think of it as a check-the-box exercise. They show up to the factory, they witness some tests, sign a document, and leave. But in fact, we're doing a lot more at the factory acceptance test. So we're building that unit with the specifications that have been designed for, and then we're really proving behavior, not function. It's pretty easy to say, does it work, yes or no, but to actually explain how it behaves dynamically in a factory environment is what we're proving at FAT. So we're going to step load that unit, we're going to block load that unit, we're going to reject the load, we're going to run it at full load for several hours, and then there's going to be a lot of paperwork and test results that get compiled together, and having that record follow the unit through the life cycle is really the key piece to FAT. And what I would say most people get wrong, or what stands out most to me with factory acceptance testing, is that what's not found or discovered in the factory can become a major issue if it's discovered on site. And that just increases the costliness of this site in both time, money, risk, safety exposure if you're at an energized site as well. So I like to think of FAT as the cheapest commissioning hour you're ever going to spend.
Yeah, I think it's quite tough though, isn't it? Because there's always a demand from clients to get it onto the site, to get it installed. And, there's been times, not naming any names, but, they've demanded kit to leave the factory when it wasn't really ready. And like you say, it just causes issues and headaches for the contractors or whoever's installing it or managing it on site. It's a big one. But as projects become larger and more modular, do you see more factory-based testing happening for you guys in particular? And how is that going to impact or improve the process?
I would say it has to, right? As Aidan was sharing, these projects have grown enormously in scale, but the timeline to deliver those projects has remained fairly stable. We're seeing multiple hyperscalers pop up in one regional location at once, and you're getting all of this demand hitting at one time. And so I truly believe the only way we're going to gain some time back, and our lever to pull here, is having more integrated factory testing prior to those units leaving the facility. And that could even look like bringing multiple units together to parallel with some of the controls equipment, and actually proving that that paralleling scheme works in reality, because while it will behave slightly differently on site than it does in a factory, being able to kind of prove that at a factory level, and then also gain the client's trust that that's going to be accepted as part of the commissioning record once it does arrive on site, that's absolutely a way to buy time as it is truly a race. And I would say the other piece that the OEM has a lot of ownership on in all of this is the labor required around commissioning this volume of units. And we're fortunate at Caterpillar that we use our dealer network. So we're pulling from a global labor pool, essentially. And what we've done is kind of looked at customer forecasts, planned out their commissioning schedule 2 years in advance, and overlaid our technician resources on top of that to say we're going to have the right people in the right place at the right time with the right skill level, and then use any gaps that we see to pull levers much further upstream in the process than scrambling to find the right appropriate site labor at the right time.
I think that's an important point. I mean, labour, I spoke on a panel 3 years ago about labour and skills, and we're still talking about the same thing. Nothing seems to have changed. But I think you're very lucky to have that visibility and to be able to plan. For CXAs and general contractors and most of the supply chain who's on the site, they don't have that luxury of foreseeing what you've just described. So I think skill in labour, especially in this industry, is really tight. And I think if whoever can unlock that challenge will ultimately be the winner of where we're heading. So Phil, on the client side, how much confidence are you now placing in off-site testing, and what's your view moving towards modular testing, and how do you see that accelerating your delivery?
That's a great point. We're really changing what commissioning looks like from a Vantage perspective, and we've been entrusted with this from our design team, really supporting us heavily. You know, we're not designing something and then we're expected to commission it anymore. It's very integrated. You know, we're one team that are designing and through the commissioning lens, ensuring that all of the blocks that are being designed can then fit together from an MEP perspective. But taking it one step back, the level 1 to 3 process now, we're really going to be doing that in the factory, right? As much of 80%, 90% of that level 3 process is targeted to be done in a factory environment. Now, that may not necessarily just be a Schneider factory or a Vertiv factory, but that may be an integrator where all of these bits of equipment come together as one, are laid out in a logistic way and proven as an end-to-end. We really are changing that, and this is in collaboration with a lot of other data center colo providers. It's not just us that are doing this. We're in talks with other businesses that want to do this with us. From an end customer perspective, from an end client perspective, they haven't struggled to get their head around this. They knew it was coming. They was aware of it. But they just wanted to very much highlight the risk of doing it. And that risk is that we spend time, effort, and money from everyone doing it in a factory, and then we ship it, and we inconsistently ship it. And that means it's subject to vibration or it's subject to whatever external forces that undo all the work that the teams have done. You know, so we've got to have a full lens from start to finish and a proper strategy in place to ensure that if we are going to invest the time and money and change that process, we're going to have the logistics in place, we're going to have the carryment in place to ensure that that equipment does come and it's still ready to go. And then we move into that site perspective where, again, we're having a hybrid approach to commissioning. It won't be a level 1 to 3 process on site. It's very much a skid and an asset-based, a child and parent-based system is how we've developed it at Vantage. And it's been met welcomely by both global, our CXMs, the likes of Aiden in the world, and our end-line customers. They're really for this process, and I think there's no world that we can go to on these large, heavy-set facilities where that's not going to happen. We're doing the model from Vantage perspective. We're a global company. Our US team, our North American team are implementing this. We've been consulting heavily with those guys out there because we've had a little bit more time to plan for this. They received some orders which meant that they had to hit the ground running and didn't quite have the right processes in place. They've had to do it on the cuff. So we've been heavily involved in consulting, and Phil and team have been very much involved in that right from the very get-go. So, yeah, it's a new world for commissioning, and it's a very exciting time.
Yeah, I think with that, again, coming back to the labour, you know, thinking about how this is all going to pan out, you're going to need lots of labour to accommodate. So, in theory, it's a better process, but you're going to need factory labour, you're going to need on-site labour, because it's not just going to be a factory process, and then everyone moves from the factory to the project. You're going to need more labour, and it's how do we manage that? How do we bridge that gap of labour from the factory to the project?
I think a lot of it is, you know, the big lens that we're looking through is if we identify an issue with the equipment, it's far better to identify the issue, as Aidan said, in the factory. They've got the technicians, they've got the spares of equipment, they've got the capability there to quickly remove something and replace it with the correct product or the correct instrument. When we do it from a site perspective like we've traditionally done it, that takes so long to get that remedy in place where it's got to go back to the factory, they've got to rewrite the code, etc. Doing it in the factories where it's going to be successful. But we do have to double our teams. And we do need collectively the industry to understand that we need to invest in people and bringing them through different. There was a team up here earlier speaking about the different environments or the different systems that are out there. Looking at you know, the oil and gas that's got a huge amount of skill set. You know, bringing those guys and girls out of oil and gas and bringing them into the data center world and encourage them that this is an industry they want to work with and work within. Is really crucial. You know, pharma comes up with another one. The pharmaceutical industry is very, very similar, but almost data centers on steroids, right? It's far cleaner, it's far more precise. We don't need to be quite as precise and far as clean, but when we work in this AI world now, the constraint on the water quality is really quite granular. So it's going to take individuals like that have been tried and tested, doing this for 30, 40 years. We're going to need to bring those in and bring them in fast.
No, I agree. Aidan, what's your view on this? Obviously, from a GC perspective, talking about modular and how we're going to move it through that. How do you see that affecting your delivery?
I think it's a huge benefit to us, but you need to know the questions that you're asking and have the right stakeholders. Like if we watch the number of person hours that we expend every year, and we've seen a rapid increase, and to put it in perspective, we're just one GC as Winthrop Technologies, but our rolling 12-month average is 10 million person hours. That's 5,000 people every day of the week across our business unit, and that's going to go north. Then when you start factoring in what Laura was mentioning in relation to the off-site manufacturing, that could be another 8 to 10%. So if we can take any amount of that 10 million person hours away from the coal face, because you can only fit so many people on a site, you can only fly so many people into a region. So if we can diversify those tests and make them more effective, you've got multiple work fronts. There was a modularization panel talking about it here earlier on. If you create that design that's repeatable and get the right stakeholders conducting the right scripts, we can never test everything to 100% in an off-site manufacturing facility, but we can get a huge amount of it to 100% at that stage. And again, you're taking that workforce away. You're also getting the right stakeholders, as Phil just touched on. When you have something that doesn't work, and it's like one of our clients said to us before, Aidan, you're allowed to find issues at commissioning. That's your job. You find them, you fix them, and you move on. So a lot of people have this thing, when something goes wrong, they're afraid to report it. That's our job. You're trying to pull together multiple things that mightn't have been pulled together before. We need to see how it works. And Laura said it as well. How does it react in the environment amongst everything else? There's a set deliverable criteria for pass-fail criteria. We need to agree that up front, say what can be tested, what can't be tested, get an effective way of testing, whether that's bringing load banks to a particular off-site manufacturing facility, generators, chillers. We've done it with a number of the suppliers outside here today. We've done it very effectively. And I think, one, to keep us safer, that we're getting the workforce reduced at the coal face and getting those tests done in real life, or as in real life and environment as we can, in a much safer environment. But getting all of those tests, all of the comms, all of the graphics done, all of the interactions done, as much of the N and N+1 and system failures and duty standby, duty sharing, get all of that done away from the work face as much as we can, so that when it comes to site, it's already been given a serious shakedown. So you're doing then multiple repeats of kind, and you're just rehearsing and playing. It's like basically going to the theatre every night. You're doing the same thing. You know what happened yesterday. You expect the same thing happen today. But again, you need to set yourself up that it may not one the same. Equipment can and does fail. You'll have changes in personnel. You'll have changes in environmental conditions from summer to winter. So there's so many variables that between Phil Hayden's team and our team that we have to deal with. We know PUE efficiencies, so we have so many variables that we have to adjust our decisions, not just daily, weekly, but seasonally as well, as regards what can we do off-site and what can we do on-site.
No, it's a good answer. So Phil, just come to you. So obviously talking about the whole modular and how we see this sort of changing. Obviously traditionally, or in the past, and it sometimes still happens now, is some clients only bring CXAs in at level 4. Or level 3 into level 4 IST. Obviously, a lot more clients now are engaging CXAs through the design stage. I mean, I think we're all big advocates of the earlier the better. Some clients still aren't like that. Probably down to a cost thing, to be honest, but I don't think they see the real benefit of that. How do you see, what is the benefit of coming in earlier? What is your view on why we think it's better to come in earlier? And linking to the modular, how do you see that sort of working for the CXA?
Yeah, I think what Phil mentioned earlier on is we need to rip the rulebook up. We need to still stay within the guidelines of what we've got, but we need to get early engagement, build in with the modular view of how we're going to test it. Things like skip matrices. What can we do in the factory, achieve everything? What can we do outside of the factory? How do we work with the OEMs right at the design stage? So when these guys are being procured, are we working hard enough to cover off everybody's standards right at the very beginning of what we're looking to deliver? And the other big thing is diversification. Are we actually using the right people for the right job? Fundamentally, for us, we're 90% degree qualified or real engineering rates all the way through our company. Now, are the right people doing the right jobs? Because actually, would a QA man be better off in a factory? Would a person who is, my bad, a person who is actually solely focused on testing be better further on down the line? Do we need those engineers right early? The answer is we probably don't. What we need is people from a commissioning design perspective working alongside Jamie and his team. We need engineering specialists working alongside Aidan or Phil, and basically just creating that overall view and package. And like I said, the only way to do that is to rip the rulebook up, start again, stay within the guidelines, but work together all the people on this panel would be able to sit in a room and make the commissioning process from beginning all the way to handover to operations a better perspective.
I'm just very conscious of time. I've got a lot of questions. I'll have to skip through some of them. Laura, back to you. So with the equipment lead times, obviously you probably know more than anyone. Phase delivery, grid constraints, how's that affecting what you're delivering in the traditional model of getting equipment to site, construction, testing, handover? How are you managing the constraints of lead times?
Yeah, it's a real challenge in our industry right now. I'm sure no one in the room is surprised to hear that generator lead times are at the forefront of the challenge in the industry. Many primary markets for data centers across the globe, you think of Dublin, Northern Virginia, parts of the Nordics, they all have grid challenges right now. And I really think these two challenges compound one another. You have, let's say, typical commissioning is more of a linear process. You know, you design the building, you build the building, it becomes energized, you go through the 5 or 6 levels of commissioning, however you would like to classify it, and it goes into the handover phase. But with these challenges right now, you to copy your words, you have to throw the rule book out the window. You can't assume that there's any buffer in your schedule anymore. You're dealing with these real world challenges. And so oftentimes with the power generation assets that are sold for a primary backup use case, those might have to be utilized as the primary source of power for a particular amount of time, which accelerates the wear on those units as well. You talk about a partially energized building. That's extreme safety risk for the people working on that site. It also is requiring a need for additional equipment on site like load banks to do a different type of commissioning because you don't have the key components that are required, such as utility power and backup power. So it really is creating a lot of challenges, and I think the pre-planning and the partnership methodology is how we overcome that. It's talking with the design team up front, talking with the OEM, the client, understanding needs, so you stop talking in lead time and you start talking about what is the supply and demand between this partnership and how do we work to deliver on our commitments.
No, that's an excellent point. And just coming back to you, Jamie, thinking about grid constraints, supply chain, how do you design for that? Thinking about phase delivery, commissionability, how do you sort of plan for that?
Most of our projects have this demand of speed to market. Yeah, and in this world of grid constraints, we don't normally have all the power day one. We might not have any power. We might have to find a temporary solution, whatever that might be. That in itself becomes a challenge. Yeah, if we build a chilled water system, we don't have all the power to supply all the load that's going to be fed from that system. Yeah, how are we going to design that to be commissionable in a phased approach? Yeah, how are we going to anticipate the level of control that's going to be needed to integrate load onto live systems? So that's where we see maybe some challenges from those grid constraints.
Yeah, I think it's really a tough one to unlock. Where do we think the industry's heading in this space? Phil, I'm looking at you. From a client side, I mean, we've touched on it briefly. All these new sophisticated buildings, delivery programs. Where are we heading with this? How do we unlock the challenges that we're facing in this space?
To be honest with you, Louis, the best model that our CTO has brought together is simplification and not complicating these buildings. Don't build basements. Don't build 6-story facilities that take too long to build for the MEP equipment to go in, for us to commission it. It's really building as low and as flat as possible and having as much space and spread out as you can, especially with the new world of AI. It doesn't need to be in Frankfurt city centre, right? It hasn't got that requirement anymore. So it doesn't need to be constrained to that small logistical nightmare piece of land that we're all looking at. It's really spreading it out into areas in which, we're not, number one, going to disturb or upset anybody, but we're really spreading that design out. And it's repeatability. Having our CPO in our business is developing sort of 5 products that are very fungible, and any of our customer base can select one of those products and have any widget on them that they want. And it's that repeatability in the industry that's going to be crucial for us all to be successful. Moving the needle to the left is a saying that I keep coming up with, and It's really bringing the right people in at the right times to plan so that it doesn't require there to be, as Aidan said, hundreds of thousands of people that don't exist in a site location. You've got a saturation point of any site, and then it becomes dangerous. Safety should always be first. It's the first thought we should all go out with every day, and we should all make sure our teams, and we're supporting our teams to be safe in every environment.
No, I totally agree. I mean, the safe system of work, and like I said at the start, is so important, and it's something that we need to continue as an industry to focus heavily on. Very tight on time here. One last question for you, Aidan. Over the next 3 years, what's the one big change you think that we should make as an industry to improve what we're trying to deliver?
Openness, communication, and planning. We've had it over the last decade where we find there's real challenges, whether it be from law or supply chain, something as simple as being let down by a CT, generators being late. If we get together as a group as early as we can, sit with Jamie from the design side, sit with Phil from a point of view of what can your utility vendor give us. If there's not power for us for day one, and we have it on multiple sites where we're putting in temporary generator farms, but it's to get that open and agreed communication. It does have to tie back into the business plan for our clients, for all of their financing, but I think each of the stakeholders here probably will be more beneficial to be engaged that little bit earlier, understand the power constraints, understand if there is any water constraints. There's so many local sort of regulations and codes that we need to make sure we're all up to speed. But if we have visibility in that, the same way as we work with multiple design houses, we work with multiple supply chains, we're in a good position where we can say, well, this is what we believe we can do. You don't need all the power day one. What power have you got? And we can then set out a plan whereby we can demonstrate, we'll test every piece of equipment to 100% of its design capacity that we hand over to Phil. And then by the time we got to that stage, right, here's the power ramp, here's the service ramp, and then Phil and I, we work out a plan then for level 4, level 5 and IST to try and meet that demand. So communication and forward planning, I would say, would be a benefit.
Yeah, I totally agree, and I would presume everyone on the panel would agree that. I mean, honestly, I could probably sit here all day and talk about commissioning and the challenges that we face, but unfortunately, we're out of time. Is there anything anyone wants to add before we close? Have we touched on everything everyone wanted to discuss? Yeah, I think the important point of today is that if anyone takes anything away from this, is that commissioning isn't just a construction milestone. It's a life cycle discipline, and I think the more that the industry opens up and talks openly about all of this, I think the better the industry will become. So I just want to thank all of the panel, Laura, Phil, Jamie, Aidan and Phil. Thank you very much, everyone. Have a good week.
Thanks all.